Namaskar students. Today in this video, we will discuss that how to solve linear differential equations of first order. If you remember, we have discussed the general form of linear differential equations in very first introductory video. So let us start. The general form of linear differential equation of the first order is dy by dx plus py equal to q. Here p and q, they are functions of x, and this y is dependent variable and x is independent variable. In linear differential equations of first order, dependent variable, which is y here, its first order derivative, which is dy by dx, occurs in degree 1 and separately. For solving linear differential equations of first order for this particular differential equation, we will be evaluating integrating factor. We will be finding, first of all, integrating factor. We write it IF, and it is e raised to power integration of p, this p, with respect to x. With the help of this integrating factor, obtained integrating factor, we will be writing the solution of linear differential equation. Solution of linear differential equation of first order has the following form. Dependent variable, which is y here. Integrating factor, which is e integration of p dx. This is equal to integration of this q, right hand side. In product, we have the integrating factor. This one, we have to integrate it with respect to x and one constant c in solution. So this is the solution of linear differential equation of order 1. Now, we will be considering some problems. Let us consider the first one. Solve the differential equation. The equation is dy by dx equal to y tangent x minus 2 sin x. Let us name this given differential equation which we have to solve as equation 1. Now we can see here that this differential equation is a linear differential equation. So first of all, we will be writing it in the general form where the coefficient of dy by dx is 1. Here already in given equation, the coefficient of dy by dx is 1. Let us rearrange it. Rearranging the terms, we have in general form, we have dy by dx plus py. So we will be taking this term on the left hand side, dy by dx minus tangent x y, and this will be our q minus 2 sine x. We have written it in the standard form. Here I can write here for your reference that if I compare it, we have p minus tangent x, q minus 2 sine x. Now let us find out the integrating factor. We know that E, integration of P. Be very careful, we have minus sign in P, tangent x dx. When we will solve it, it will be E log, minus sign hai, it will be log cos x and it will be cos x. So we are getting the integrating factor as cos x. Now come to the solution. The solution of differential equation 1 equation one is dependent variable is y here. Integrating factor is cos x equal to integration of right hand side q, which is minus 2 sine x. Integrating factor, the integrating factor is cos x dx and the constant c. Let us solve this. Y cos x, we know that minus 2 sine x cos x, we can use here the result of sine 2x. On integration, we will get cos 2x by 2 plus c. That is 2y, if I rearrange, 2y cos x equal to cos 2x plus c. So the solution of given differential equation, this equation 1, is 2y cos x equal to cos 2x plus c. Let us consider one more problem. Solve the differential equation 1 plus y square dx equal to 10 inverse x, sorry, it's not x, take it as 10 inverse y minus x dy. So first of all, rearrange it. On rearranging, let us name this again as equation number 1. So from equation 1, we have dx by dy equal to 10 inverse y minus x 1 plus y square. We can rearrange it to write it in the standard form. When I rearrange it, dx by dy plus 1 upon 1 plus y square x equal to 10 inverse 10 inverse y 1 plus y square. Now, if you will see this differential equation here, x is dependent variable and y is independent variable. And this differential equation is linear in nature. If I compare with the standard form, it is same. The only difference is that here dependent variable is x and independent variable is y. Here p will be function of y. P is 1 upon 1 plus y square. And if I talk about q, q is 10 inverse y 1 plus y square. So we have written it in standard form. Now we will be moving ahead for finding the integrating factor. Integrating factor e. Now since p is function of y, you have to differentiate p we have to not differentiate, integrate. We have integration here. We have to integrate this p with respect to y. So e this integration 1 upon 1 plus y square dy. We get integrating factor standard integration e raised to power 10 inverse y. Now we have integrating factor. Now the solution of this differential equation which we are considering will be dependent variable, which is in this problem x, then integrating factor which we have obtained right now e raised to power 10 inverse y, and equal to right hand side q, which is e 10 inverse y. This is our integrating factor, and now I am writing q. Q is 10 inverse y 1 plus y square dy and a constant c. So we have to evaluate this integration. So consider, let us name this as equation 2. This is the solution. Here we have to evaluate this integral. Let us assume this integral as I, and we will be evaluating it separately instead of writing this equation again and again. E raised to power 10 inverse y 10 inverse y 1 plus y square dy. It can be easily solved with the help of substitution. Let us assume this 10 inverse y as a new variable. Let 10 inverse y as t. Then dt by, this will imply that dt by dy will be 1 upon 1 plus y square. This will give us I in integration, which we have assumed as I, integral. We have assumed 10 inverse y as t, this 10 inverse y as t, and dy upon 1 plus y square will be dt. When we will use here by parts, we will get t e raised to power t minus e raised to power t. Let us put here t. E raised to power t is common. T is 10 inverse y 10 inverse y minus 1. So this is the value of this integration I. So the solution of given differential equation is x integrating factor e raised to power 10 inverse y equal to the result which we get from integral e 10 inverse y 10 inverse y minus 1 plus c, that is x equal to, if I simplify it further, 10 inverse y minus 1 plus c e raised to power minus 10 inverse y. So this is a solution of given differential equation. In the same manner, we can solve other linear differential equations. First of all, find integrating factor and then use the result which we have discussed for finding the solution of such equation. So this is all. Now, in next lecture, we will be talking about Bernoulli differential equations.